Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 377. Combination sum 4. So in this video, for this problem, we are going to share a method based on dynamic programming with early stopping or early break. So actually in the previous video, we shared a solution using backtracking for Leetcode problem 40, combination sum 2. So it's actually good to compare the two solution formats for these two problems. So here the problem asks us to return the number of possible combinations that add up to a specific target. So in this example, a difference from the previous Leetcode problem 40 is that so for each of the elements we can use it multi times. So this is specified in example 1. For example, this number 1 used 4 times to get target 4. So we have 1, 1, 1, 1, right? So in example 2, I guess this is a special case. So the num contains a single number, none. The target is 3. So 3 is less than none, so the return is 0. So the constraints are the following. So the length of nums array is bounded above by 200, and the numbers in the nums array is bounded in between 1 and 1000, and all the elements of nums are unique, and the target is in between 1000 and 1. So this is not a very large number, we'll see. So with that said, let's look at the method. So here we're going to use dynamic programming with early stopping or break. So here, as for any dynamic programming solution, if we use a dynamic programming table, so the important thing is to determine or interpret the generic elements in the table. So here we are going to define dpi to be the number of possible combinations that add up to I. What our goal is to find the number of combinations that add up to the target, right? So here we want to specify the dp update rule. So this dp update rule actually is very natural. So if we want to check the number of possible combinations that add up to I, then we can actually scan the nums array to examine each number y. So if there are dp I-1 possible combinations to add up to I-y, then those combinations induce same number of combinations to add up to I, because we can appending each of the combinations with an element y, right? So with that said, actually here is a point we want to make. So we actually could sort the nums array to do early stopping, right? So we will specify this point in our code. So here is an example. So if we use the above analysis, the dp final state will be like this, and we are going to return 7. So let's first look at the code and then come back to this sentence. First, we're going to do some preparation. Let's see. I'm going to first sort the nums. So nums sort. So this way, it brings us some convenience. Then we're going to initialize a dp table, which contains target plus 1 element. So the first element, dp0, it means the number of ways to make up 0, so which is 1. So there's only one way. Notice that here the range of elements in nums might be shed some light here. So because each number in nums is greater or equal than 1, right? So if we want to build the number 0, so there's essentially one way. That is, we do not choose anything. So with that said, we are ready to do the dp update and with early break. So for this, we're going to look at the sum, the combine sum in range 1 to target plus 1, right? So because we have already set dp0, now we want to set dp for combination sum. So then, because we have we have sorted the nums array, we can do this. So for number, for y in nums, so if combine sum is greater than y, greater or equal than y, then we can do the DP update by this. So combine sum, so we increment by DP combine sum minus y. The reason is here. So this line of code corresponding to this update rule. So if there are DP I minus y possible combinations to add up to I minus y, so those combinations induce same number of combinations to add up to I. So by appending each with y. So you can think of I to be the combine sum here. So with that said, actually, so this is the if condition. Otherwise, so if combination sum is strictly less than y, so we cannot choose that y. So we actually just need to break. So that's the DP update. So actually that's the main work. So with that said, we can actually return the result. What we are going to return actually is DP target, right? Or DP -1. So if we like. So let's write into this format and check for a special case. Oh yeah, it passes the first case, and then let's do a generic case check. Yeah, it passes the generic case very fast. So let's also verify this DP final state by put a print here, print DP table. So for this specific example, right? So the DP state is 11247. So here's 11247. I guess with that said, that's about it for the solution format here. We are going to represent it. So you can try to write code or solutions in different formats for this solution, for this problem. So with that said, I guess that's about it. You are welcome to watch other videos in my channel.